Hi everyone, this is Elise and I'm Chloe, as you can see, our beautiful over there. We've been both working at Bricsys for 2 years now. Some of you maybe already saw us on the conference last year, or maybe if you were lucky, you saw one of our behind-the-scenes interviews with Rose. Watch out, because she's running around here somewhere. She will try to find you as well. But the reason that we are here on this stage is because we both work in the AI team, and nowadays future and AI are almost always pronounced in the same sentence. So that's why today we will give you our view on the future and our plans for the coming years. However, we won't only talk about the future, we will also have a look at the past. What did we do before, and what will we try to do in the future? We will do this by trying to answer the next question. What is now actually the point of adding AI to CAD, and what will we do in the future to achieve this?
Well, the answer to this question is that AI can help to fix even the most serious workflows. Now you might think my workflows don't need any fixing, but let me show you this pie chart with the famous Pareto principle. As you can see here, 80% of the repetitive tasks are generated from 20% of the creative design work. We at Bricsys want to decrease the time that designers spend on this repetitive task, because we think they should be able to do what they love to do and not spend most of their time at creating documentation, adding all BIM data manually. So this is why our team focuses on creating intelligent tools that can help the designer in each step of the design process by eliminating some time-consuming steps out of it. And also we want to make it possible to work with multiple alternatives at the same time and to even easily change something to your project in a later phase. Simply said, we just want to give them the freedom to be really creative.
So we try to find the most time-consuming and the most tedious workflows, and in each of these workflows we try to define the steps where we think that AI can give a lot of improvements. So in the last years, we already filtered out about 3 workflows on which we already made a lot of progress. So let's have a look at one of the first workflows where we started. And this is the adding of BIM data to a model. In Bricsys, we have the philosophy geometry first. And that's why, in the end, it can become very hard and a lot of manual work to add the BIM data afterwards. And that's why, with the AI team, we tried to make this manual work a lot easier. Most of you probably already recognize the first icon that is shown there, and that's the icon of BIMify. BIMify was our first step towards helping the user to add BIM data to their model. BIMify automatically detects the correct BIM type of a solid. It detects which solids combine together into a building, what the stories of these buildings are, and on top of that, it recognizes the rooms, which walls are external and which ones aren't, and it also detects the standard profiles corresponding to the linear elements, such as beams and columns. Before BIMify, the user had to do this all manually, but now in every stage of the design process, he can ask BIMify to add some more BIM data without changing anything that he did before.
After creating BIMify, we noticed that there is still a lot of BIM data that the user has to set manually. Think about all the window parameters that you have to set, or all the compositions that you have to add. Often behind this, there's a very clear logic behind this. So an algorithm should be able to do this job for you. And this is why we created AutoMatch. As the name suggests, it does an automatic matching of BIM data in your model. The special thing about AutoMatch is that it can not only learn from examples in your current model, but you can also use an external file for AutoMatch. AutoMatch can now be used for window parameters, stair parameters, compositions, and also for all BIM properties in general. As you can see here on the left side, the situation before AutoMatch. So there are no compositions yet, and also the window parameters are just the default ones. We already did the effort to set all of these things correct in another file, and then we will just let AutoMatch use it, and we get the situation on the right side. So all the compositions were added, and also all the window parameters were set as we want. When you want to know more about this, then I want to encourage you to come to the BIM workflow session tomorrow afternoon, Or if you can't wait until then please come back after the break for the BIM Ultimate Workflow session. For the future, we want to continue to improve our AI algorithms, and the way that we want to do that is by making them more personalized and more tailored to your needs. For example, a structural engineer needs a different tuned algorithm than a residential architect.
So you can see that already improving one workflow can make a big difference. But we can repeat the same exercise not only for workflows in BIM, but also for workflows in BricsCAD. For example, 2D and 3D drawings can become very complex and very large, so it's important that you keep them organized. The better that your drawings are organized, the easier that they become to manage and even to make changes afterwards. And that's why last year we made Blockify and Parameterize. Blockify detects the repeated geometry in a drawing and will replace this geometry by block references. This doesn't only reduce the file size a lot, but it also makes it much easier to make changes afterwards. In the same thought process, we created Parameterize. Using Parameterize, a set of 3D constraints are created for a set of solids. And now it becomes much easier to create several versions just by changing some parameters. It was a lot of manual work to do this yourself. I tried it and it's very frustrating. So now using Parameterize, this is much easier. However, we realized that we could go much further than this. Blockify was creating blocks, but what if these blocks form a specific pattern? Wouldn't it be nice that Blockify also recognizes this pattern and creates arrays for this? So that's what Heidi already showed you before. Blockify now has an option to replace patterns by arrays. This way, it becomes even much easier to change that pattern afterwards. We didn't only include this array detection in Blockify, but we also added it in the mechanical context to create MEP branching tools and to create sheet metal features. If you want to know more about that, you can come back right after the break where Jacob will demonstrate this, or you can come back tomorrow for the BricsCAD mechanical session if you want to dig more deeper into it. But we didn't only stop with Blockify. We realized that also Parameterize could be extended. So we created this tool in 3D and it's very handy, but why didn't we create it in 2D as well? And that's when we started developing Parameterize 2D or Auto Constraint. It's a very good starting point. It's not perfect yet, but after a few small changes, you are left with a completely parameterized model that you can start inserting into your drawing, as Heidi also demonstrated before. Oei. Technology is failing again. What happened? Ah, it's back.
So for the future, we want to continue to improve Blockify by making it possible to do advanced 3D pattern recognition on your full model, but also on assemblies. We also want to improve Parameterize to make it possible to make these constraints that you get only the ones that you want. And we also want to bring these two together so that it's possible to parameterize the patterns that Blockify has found. The last workflow that we want to have a look at is the detailing workflow. We believe that this is a very important workflow because creating all these details manually can take a lot of time. And also, it's really important that all your details are there because you do not want to be left with an incomplete 3D BIM model. So I think everyone knows Propagate by now, but for the people that have been hiding behind a rock for the past 2 years or are simply new to BricsCAD, well, for them I want to explain the main idea behind it. So with Propagate, you only create your detail once, and then Propagate will find all similar locations in your model where this detail might fit. Also, you can choose to accept all these suggestions that Propagate gives you, but you can also choose to only apply a few, so the user is still in full control. After creating Propagate, we immediately got a lot of questions. What if I want to use the same detail, but on walls with different compositions or different thicknesses? Or what if I want to use the same detail, but on beams with different profiles? Well, for V20, we answered this question by making it possible to use parametric details in Propagate. So now Propagate will not only find the exact locations where your details might fit, but it will also find the locations that lie in the ranges of your parameters. So this means that it will now work on beams with different profiles, but will also work when your base entities, like members, lie in different angles. Another thing that we did for V20, which Erik briefly mentioned, is that it's possible to save and load your details in a library. That way you can use the details that come back in several drawings, or also it's also very handy for the details that take a long time to make. Then in your new drawing, you just simply use drag and drop on your drawing, and Propagate will do the rest for you.
I will just let the video finish.
So as you can see, all the suggestions are here. And we did a different profile, and also there the suggestion is added.
If you're interested in this, you can see Propagate in all the sessions, especially after the break, where Jacob will demonstrate it to you. And if he's going a bit too fast, like Jacob always does, you can come back tomorrow for the BricsCAD BIM more in-depth session. But as with Parameterize, where we went from 3D to 2D, we realized that also Propagate would be very nice in 2D. And that's when we came up with Copy Guided. In Copy Guided, you select the region of your drawing, and then you can start moving around with it. Copy Guided guides you to the location where this detail fits. And as with Propagate, where the base entities were adjusted as in your original detail, now Copy Guided adjusts the guide curves by trimming and joining them. You can even start misusing Copy Guided, as Heidi did, to use it as a patching tool, to just remove parts of your drawing that you don't want to be there anymore, and Copy Guided fixes everything for you. But now we have this functionality of Copy Guided and Parameterize, but probably you want to use the same door or the same chair in another drawing as well. And that's when we came up with the concept of parametric blocks. These parametric blocks aren't just ordinary blocks, but these are blocks that are extended with parametric behavior. So you can use Copy Guided, you can use Parameterize, but we didn't stop by just adding that. We also added the possibility to define flip lines and to define visibility states. So you can save all your blocks in a panel, and then just by dragging and dropping from the panel, you can start inserting them into your drawing. Then if you look at the different parameters, you can start playing around with them. So you can start changing the flip parameters to flip your blocks, or you can just have a look at the visibility parameters to switch from different visibility states. For example, if you insert a toilet, you can use the flip line to flip the side of the handle, or you can use the visibility parameters to switch from a toilet to a sink. So this way it becomes very easy to add all these parametric blocks into your drawings and to create them all by yourself. So probably the first day of the release, you will start running home and start filling up your libraries. But soon enough, these libraries will become very big, and it will become even time-consuming to search for that perfect detail or that perfect parametric block that you are looking for. And that's why in the future, we want to make these libraries smarter, such that they show you the relevant details or the relevant parametric blocks that you're looking for. So you see, we already filtered out a lot of workflows where we worked on, but there are still many, many more workflows where we want to have a look at. For example, the creation of design documentation out of a BIM model can be very time-consuming, let alone if you want to make some changes afterwards. Or for example, the validation of design requirements is also one of the workflows where we think that AI can improve a lot. But if you have any other workflow where you think, okay, I'm losing a lot of time here, please let us know and we can have a look at what we can do.
Yes, please, if you have any questions about our presentation or like Chloe's suggested any new workflows that you want us to improve, please tweet by using the hashtag Bricsys 2019. I'm sure that some of you have noticed a trend in our presentation, apart from our beautiful timelines, of course. Well, on the futures part of our timeline, you could see that we want not only to include new workflows, but we also want to improve the ones that we have by making them more personalized and more tailored to your needs. A classical algorithm typically gives you the same output when you give it the same input, but AI algorithms can learn from your data and really get personalized for you.
And the best way that we see to do this is if you would join forces with Bricsys 24/7. If your current drawings are on 24/7 and the AI algorithm is in the cloud as well, it will be possible to learn much more and to improve much more towards your needs and towards the results that you're expecting to get. However, you don't have to start panicking. We will anonymize all these data, so we won't be able to make fun of you or of your bad designs. Okay, thank you very much. We will give the floor to Geert now, and he will talk about his future using VR.
And point clouds.
And point clouds. Thank you very much.
Okay, good morning. My name is Geert Machtlink. I work as a software engineer at Bricsys, mainly on VR and related technologies. So I'll be showing you, if everything goes well, some of the progress we made in the last couple of months, in the last year. And I'll be focusing mainly on two topics. The first is the visualization of extremely large point clouds in VR and other devices. And the second is actually streaming that data for visualization over the internet. Maybe a quick show of hands. Who works with point clouds? Or not necessarily in BricsCAD, but any software? Okay, you wish your computer was 100 times faster, right? Because you're dealing with a lot of data, and that can get frustrating because you're copying over data, you're waiting. But your computer is not going to get faster. Actually, it gets worse. As scanners get more sophisticated, resolutions go up, they scan faster. You can expect the volume of data to grow faster than the speed of your computer. So that's a challenge for us software engineers. How can we make you more productive with point clouds? How can we make it less frustrating? How can we make it more fun to work with big data sets? Okay, I have actually two data sets I want to show you. They are big. The first one is the largest data set I have. If I would have a bigger one, I'd show you a bigger one. It's almost 1 terabyte of LAS files. So that's a big point cloud, which is a challenge to visualize, to work with. It's a scan of a small town in Belgium, Knokke. It's a coastal town of about 30,000 inhabitants. All streets have been scanned by a company called Tecon in Belgium. And I'm going to fly you through it. The resolution is not super high, but what I want you to understand and hopefully appreciate is the scale of this monster. So that's the coast. This point cloud has 25 billion points. Anyone working with point clouds larger than that? Larger than 1 terabyte? I think I saw a hand there. I want to talk to you. I need his data. Okay. Let me fly you through. Actually, this data set, it's not super high resolution. It's not very polished. It's the raw data. But as you come closer, it streams in the details. I think the spacing between the points is like 2 to 3 centimeters. As you can see, it is the raw data that has been scanned. And I can fly to any place. It will just stream in the details. randomly. So it's like Street View on steroids, right? I can just look around. Okay, so this is one data set. I think you can appreciate the scale of this. I will show you another data set which is completely different in nature. It's slightly smaller, but it's still half a terabyte. I think you already saw it. Hans showed you in BricsCAD. This is a cathedral in France. The PTX files are like, yeah, half a terabyte. Let me show you a little bit the scale of this thing. The dots that you see here, the bubbles, those are the actual scan positions. Yeah, that's where the scanner scanned is. There are 320 of them. Let me fly into a random one. And it's going to stream in the details. Yeah. So actually, that is the native data. So the software doesn't go and sample down the data. It will use the original resolution. What you should understand here is that this is not a textured mesh. So it's all the original data is there. For me, for you, that is pretty flat on the screen. But for me, I can see the 3D grooves in that wall. Yeah. So every little detail. Let me turn that on again. So here you have the merged point cloud. And it's actually streaming this from an SSD I have here. Actually, I have this data set since a couple of weeks. And I've been sitting here daily praying that this demo would go well. So, okay, so far so good. As you can see, it streams extremely fast. And it's doing so from an SSD I have right here. Okay, I'm running this on a pretty powerful gaming laptop. So, okay, it works well. It works better on a maxed out graphical workstation, obviously. But what about the other end of the spectrum? What about, like, your old laptop? Or, you know, a tablet? Wouldn't it be great to be able to work with these huge point clouds as you do on your desktop, on your phone? Yeah. Actually, I have something working here. What I have here, I have this since 2 weeks working, so let's hope it works right. This, what you're seeing, is the screen of a Windows tablet, a 500 euro Windows tablet, and I'm going to start the very same data set. So this is a low-end device. The specifications are pretty similar to the phone you have in your pocket. Yeah? And right now it is loading the half a terabyte point cloud from the SSD. Yeah? It's running exactly the same application as I was running on my laptop, and it works fine. It streams in the data. You will see everything on the native resolution of, you know, how it was scanned. If I go into a bubble, you see all the details. So I have this working since 2 weeks on this tablet, and I'm pretty confident now that we will get this working on your phone. Yeah? For any size of point cloud. Yeah? Okay, there's just one elephant in the room here. I don't know if you see it. It's this SSD. Yeah? I don't think you want to go around carrying your SSD to all your devices. What you want is your data to be somewhere in the cloud, and you would access it from your maxed out graphical VR workstation or your phone as if the data was local. Yeah? That's what you really want. And actually, we have that working since recently as well. I'm going to show you exactly the same data set, and I hope the network, I hope you're all stopping to download the latest BricsCAD beta, because I'm going to need some bandwidth here. Yeah, right. Okay. So I've just booted up another version with the same data set. You will see it's not as fast as it was before, but I think you will appreciate that this is very, very workable. Yeah? The data is somewhere, I have no clue where, on the Google server, so the 0.5 terabyte point cloud, and you can just fly through, and depending obviously on the bandwidth of your connection, it's going to stream all the details. Yeah? So this is exactly the same data set. Let me go into this bubble. You can see it streams slower than from the SSD, obviously, but it's still fast enough to, to be productive. So, which concludes more or less my demo, except one thing. What you've seen on the screen, that's not really anything new, probably. You have to try this. So tomorrow I'll be setting up 2 installations, and you're all invited to pass by and try this with your headset, because it's a completely different experience. Which concludes my demo. Thank you very much.